All right, so this lecture we're going to talk a little bit about information from chapter 21 and then some information from chapter 22. I mean chapter 20 in addition, not chapter 22. So we're going to talk about how nutrients and energy flow through ecosystems. And we'll talk about kind of the energy pyramid and food chains and food webs during this little mini lecture. So we've already talked about ecosystems. We've kind of talked extensively about the abiotic factors of ecosystems, right? So just to kind of refresh, we have stated that an ecosystem, as it says, is a large community of organisms that interact with each other, and they're also interacting with their physical environment. And we talked about the biotic component that they interact with, which is that living component, and as well as the abiotic component, the non-living, which is more of the physical environment. So as we said, we've talked a lot about the abiotic factors of ecosystems, but what about the biotic factors? So we're going to move into that discussion. So like I said, we've already talked about the hydrologic cycle, and we talked about nutrient cycles as far as phosphorus and nitrogen and carbon. And so what's left is talking about the energy cycle. So it says energy and nutrients move through the ecosystems in very distinctive patterns. And we're going to see two different patterns with these. Now, almost all the energy that's available to us on Earth comes from the sun. So plants are fundamental to all life on Earth because they have the ability to trap solar energy and to use this energy to build living tissues. So since plants do not need to feed on other organisms, they are called autotrophs, and this means that they are self-feeders. Plants can also be called producers when we're considering them in relationship with other organisms. And that's because they can make their own food. So we consider them to be producers. They're producing energy that is then available to other organisms. So they're autotrophs because they make their own food. So on land it says these are mainly going to be your plants. In water, it's mainly your photosynthetic plankton, your little microscopic organisms. Now, animals, on the other hand, cannot make their own food, but they must eat other organisms to obtain energy that's needed for their survival. Therefore, they are called consumers. So consumers can also be called heterotrophs, referring to organisms that are nourished from other sources, basically from eating other organisms. And under that, we can talk about herbivores, which are sometimes called primary consumers because they are the first in the food chain to feed on the plants. So if we have our producers that are converting the energy from the sun into chemical energy and building their own tissues, building their bodies, and growing. Then we have the organisms that are going to be eating the plants. So these are the herbivores, or in our food chains, we call them the primary consumers. So they are the first ones to consume the lowest level of our food chains. Then we have carnivores, which are animals that eat the flesh of other animals. So herbivores are eating plants and carnivores are eating animals. So carnivores can be large, like we would typically think of like a tiger, or they could be small like a ladybug that's eating other insects, or even smaller, such as a little tiny amoeba. And they can be called secondary consumers because they eat the primary consumer. And then there are even tertiary consumers, that we can talk about, which are basically carnivores that eat other carnivores. So we're kind of working our way up kind of through our food chain. So there are a few insect-eating plants that we could say are both producers and consumers, and many animals such as pigs and bears and rats and humans are what we call omnivores. So these are animals that eat both plants and animals. So they're kind of an herbivore and a carnivore, so we're going to call them an omnivore. Then we have scavengers, which are animals that eat dead plant and animal matter. So a vulture is a scavenger because it eats dead animals. A termite is in the same classification because it feeds on dead and decaying wood. And then we've got our decomposers, which we've already talked a lot about this semester. So every ecosystem needs decomposers. So these are heterotrophic organisms that feed solely on dead organic matter. So the bulk of decomposition is actually carried out by bacteria and fungi and protozoans. And so they're truly breaking down that plant body completely and returning the nutrients back to the ecosystem. So what we've been talking about has been pretty much a food chain. So we've been talking about kind of a simple, kind of linear look at our ecosystem and how the organisms are interacting with each other. So here we've got the example in red where we've got the grasses and the willow and the berry, which are our primary producers that are eaten by the elk, which is our primary consumer, and the elk in turn is eaten by the gray wolf, which would be our secondary consumer. So you look for the arrows to see where they're heading, and that shows the organism that is eating the one where the arrow originated. So that would be a simple food chain, that example, from producer to primary consumer to secondary consumer. Okay. So in an ecosystem, though, a lot of times they're rarely so orderly and linear. And many times organisms occupy several different levels simultaneously. So these are kind of a lot of times what we call trophic levels. So, for instance, green plants make up the first trophic level because they're providing that energy to start with. And then herbivores make up your second trophic level. And then higher trophic levels are composed of your carnivores. So, for instance, a grasshopper that eats grass belongs to the second trophic level. Plants would be, or the grass would be your first trophic level, the grasshopper would be your second trophic level, and the shrew that eats the grasshopper would be your third trophic level. Okay, so energy kind of progresses through these food chains from primary consumer, secondary consumer, and so on. And we've got organisms that are occupying a lot of these different trophic levels kind of simultaneously. So a raven can be a primary consumer when it eats corn. It can be a secondary consumer when it eats grasshoppers. And it can be a tertiary consumer if it manages to catch a small snake and eat that. And then ravens sometimes will be scavengers. They'll eat different dead organisms that they find. Okay. So in all ecosystems, kind of this pattern of consumption can be very complicated. And so the term food web a lot of times is much more descriptive because there are various cross links between the various organisms. So I have the question here for this food web, all right, which species are the producers? So that would be your autotrophs, right? These are the grass, the willow, and the berries. Now, which species are primary consumers? So the primary consumers are the ones that are herbivores or eating the plants. So that would be your snowshoe hare, that would be the vole, that would be the red fox, the coyote, the pronghorn deer, and the elk. These are all our primary consumers. Then it asks which species are secondary consumers of the snowshoe hare. So who's eating the hare? It would be your red fox and your gray wolf. Okay, so hopefully you can kind of follow through these food webs here. So we've been talking about these trophic levels, and we said at the base of the trophic level are the autotrophs, or our primary producers. So these are the ones that are initially capturing that energy from the sun. And as we move up our trophic level, we've got our primary consumers that are eating our producers. And then we've got our secondary consumers eating our primary consumers, and so forth. We can go up to tertiary, quaternary if you wanted to, but it usually doesn't go that high. So what we want to focus on now is more about the energy and how much energy is actually being passed from one level to the next, and so forth. We've kind of seen how organisms kind of interact with each other, and in this kind of web of consumption, and having our decomposers that help to return nutrients to the soil. But let's look at how much energy is actually passed through these systems. So as energy passes from one trophic level to the next, right, some of the useful energy is lost. And that's simply due to the chemical reactions that are taking place. Because much of this loss of energy is in the form of what we call low quality heat. And that heat is then dissipated to the surroundings and helps to warm the air and the water and the soil. All right, so if you think about it, organisms go through that process of cellular respiration to convert the energy that's stored within the molecules to ATP. But it's not 100% efficient, this conversion to ATP. Not all the energy is converted to ATP. Some of that energy is lost as the form of heat. So heat is given off. So that's why we have this loss as metabolic heat. So the organisms also have to expend energy to maintain their own life processes. So it takes energy to find food, to defend nests, to walk to watering holes, or to raise offspring. So they're using that energy. And then even when they're consuming other organisms and obtaining energy that way, a lot of times they're not processing all that energy, right? Some of the energy is excreted out as waste, or it's not consumed. So not all the energy is going to be passed on from one trophic level to the next. So therefore, the amount of energy contained in higher trophic levels, I should say, is considerably less than that at the lower levels. So we say that approximately 90% of the useful energy is lost with each transfer to the next highest trophic level. So in any ecosystem, the amount of energy contained in the herbivore trophic level is only about 10% of the energy that was contained in the producer trophic level. And the amount of energy at the third trophic level is approximately 1% of that is found at the first trophic level. All right. So we lose about 10% of the energy every time we move up a trophic level. So as it says, energy is only going to flow in one direction through the ecosystem. So from producer all the way up through the consumer, we're losing, or we're only able to pass on 10% of that energy to the next trophic level. And the energy does not return back to the original producers. at the end.